Imagine the vast emptiness of space. It's not just an empty void, it's a canvas of cosmic dust and gas, a giant molecular cloud, the birthplace of stars. This cold, dark cloud, light years across, holds the raw materials for the universe's most magnificent creations. It's a stellar nursery, a place where gravity weaves its magic. Within these clouds, atoms of hydrogen and helium, remnants of the Big Bang, mingle with heavier elements forged in the hearts of long-dead stars. These particles, drawn together by an invisible force, begin a cosmic ballet. They clump together, their mutual gravitational attraction growing stronger as their density increases. This slow dance of matter marks the first chapter in the life story of every star, including our own sun. It's a story that began billions of years ago, a tale of cosmic evolution that continues to unfold even today. Our sun, like countless other stars scattered across the universe, traces its lineage back to such a cloud of gas and dust. It's a humbling thought, knowing that our very existence is intertwined with these cosmic events that transpired eons ago. As more and more matter gets pulled into the central region of the collapsing cloud, the temperature and pressure at its heart begin to soar. The once cold and dark cloud transforms into a swirling vortex of hot gas and dust. This is the protostar, the embryonic stage of a star's life. Gravity, the relentless sculptor of the cosmos, continues to draw material inwards. The protostar's core becomes denser and denser, hotter and hotter. The temperature at the core becomes a crucible, reaching millions of degrees Celsius. The protostar, though not yet a true star, begins to glow with an intense infrared radiation. This phase, marked by intense heat and pressure, sets the stage for the next crucial chapter in the star's life. The moment when it truly ignites and earns its place among the celestial fireballs we call stars. Deep within the heart of the protostar, a dramatic transformation is about to occur. The temperature and pressure have reached a critical point, a threshold where the very fabric of matter is altered. This is the moment of ignition, the birth of a star. Under these extreme conditions, hydrogen atoms, the simplest and most abundant element in the universe, are no longer content to exist independently. They are forced to fuse together, a process known as nuclear fusion. This fusion of hydrogen atoms into helium releases an incredible amount of energy, the energy that makes stars shine. This nuclear fusion is the engine that powers a star. It's a self-sustaining process, a delicate balance between the inward pull of gravity and the outward push of radiation pressure from the nuclear reactions. This balance defines a star's main sequence lifetime, the longest stage in its life cycle. Our sun, now a newborn star, entered a turbulent phase known as the T Tauri phase. This stage is characterized by intense stellar winds, streams of charged particles that blast out from the star's poles. These winds, far more powerful than the solar wind we experience today, carved out a cavity in the surrounding cloud of gas and dust. The T Tauri phase is a period of intense activity and change. The young sun was spinning much faster than it does today, and its magnetic field was far more powerful. This led to frequent and intense solar flares, eruptions of energy far more powerful than anything we observe on the sun today. While these outbursts might seem destructive, they played a crucial role in shaping the early solar system. The solar wind pushed away the remaining gas and dust, clearing the way for the formation of planets. The material that wasn't blown away by the solar wind eventually coalesced into the planets, moons, asteroids, and comets that make up our solar system. Section 5. Our Sun, the golden guardian of life. Today, billions of years later, our Sun is a mature star shining steadily in the prime of its life. It's a yellow dwarf star, a rather ordinary type of star in the grand scheme of the cosmos, but for us it's anything but ordinary. The Sun is the center of our solar system, the anchor around which our planet and all the others revolve. It's the source of our light, our warmth, and the very energy that drives life on Earth. The Sun's gravity holds our solar system together, keeping everything from the largest planets to the smallest particles of debris in its orbit. Its light and heat provide the energy for photosynthesis, the process by which plants convert sunlight into chemical energy, forming the base of the food chain for almost all life on Earth. The Sun is not just a giant ball of fire in the sky. It's a complex and dynamic object with its own internal structure and processes that drive its behavior. Its influence extends far beyond its visible surface, shaping the environment of the entire solar system through its powerful magnetic field and the stream of charged particles it constantly emits, known as the solar wind. Section 6. Unveiling the solar engine, a glimpse inside. The Sun is not a solid object like the Earth. It's a giant ball of plasma, a superheated state of matter where electrons are stripped from atoms, creating a sea of charged particles. These particles are constantly in motion, driven by the intense heat and pressure at the Sun's core. The Sun's interior is divided into several layers, each with its own unique properties. The core is the hottest and densest part, where nuclear fusion takes place, converting hydrogen into helium and releasing the energy that powers the Sun. Surrounding the core is the radiative zone, where energy is transported outward through a process of absorption and re-emission of photons. Above the radiative zone lies the convective zone, where energy is transported through the movement of plasma, similar to the way boiling water circulates heat. This churning motion creates magnetic fields that extend outward from the Sun's interior, shaping its atmosphere and driving its dynamic activity. The Sun's visible surface, called the photosphere, is a relatively cool layer, at least compared to the intense heat of the interior. It's from the photosphere that we receive sunlight, but the Sun's atmosphere extends far beyond the photosphere, encompassing the chromosphere, a layer of tenuous gas visible during solar eclipses, and the corona, a superheated outer atmosphere that extends millions of kilometers into space. Section 7. The Twilight Years, a swan song in the cosmos. As our Sun continues its journey through the cosmos, a time will come when its hydrogen fuel begins to run low. This marks the beginning of the Sun's twilight years, a dramatic transformation that will have profound consequences for the entire solar system. As the hydrogen in its core is depleted, the Sun will begin to fuse helium into heavier elements, a process that releases even more energy. This increased energy output will cause the Sun to expand dramatically, swelling into a red giant star. Its outer layers will engulf the inner planets, including Mercury, Venus, and likely even Earth. Eventually, the Sun will exhaust its nuclear fuel entirely. Its outer layers will be cast off into space, forming a beautiful, glowing cloud of gas and dust, known as a planetary nebula. The Sun's core will remain behind, a dense, hot remnant called a white dwarf star. This white dwarf, no longer generating energy through fusion, will slowly cool and fade over billions of years, eventually becoming a black dwarf, a cold, dark ember in the vastness of space. Section 8. A legacy etched in starlight. The Sun's story is a reminder of the impermanence of all things in the universe, even stars. Those seemingly eternal beacons in the night sky have a lifespan. They are born, they live, and they eventually die. But in their death they seed the cosmos with the raw materials for new generations of stars and planets. The Sun's legacy extends far beyond its eventual demise. Its life and death are an integral part of the cosmic cycle of stellar evolution, a cycle that has been repeating itself for billions of years, creating the elements that make up everything we see around us. As we gaze up at the night sky, we are witnessing this cycle in action. Every star we see is a testament to the power of gravity, the transformative energy of nuclear fusion, and the interconnectedness of all things in the universe. And our own sun, the star that gives us life, is a constant reminder of our place in this grand cosmic scheme.